All right, hey, everybody. So this is page number 3. It's not technically page 3, it's whatever. It's question 5 and 6. And I think 7 too down at the bottom. On reflection and this idea of images and things. So real quick, this is not too complicated. Two big ideas. There are two types of reflection. The one that just reflects light in all directions, called diffuse reflection, and the type that bounces it with the law. Well, I guess they all use the law of reflection, but because it's a smooth surface, all the rays bounce the same way, and so you can create an image in that. Notice with the rough surface here, they all follow the law of reflection, right, each time, but because the normals are all over the place, the light gets scattered in all directions. And so it doesn't create an image because the light gets all mixed up and jumbled. So you just see the object like we normally see most of the world. So anyway, what type of reflection is illustrated here? This is called diffuse reflection, and it's a scattered light in all directions there. And examples of things that diffuse reflection is most objects. Most objects, again, like the moon. I don't know why we always use the moon. It's not even on the earth. Moon, trees, because I always look at trees, I guess. Trees. I always use the cabinets in the room. I don't know why, but cabinets. Can't even spell cabinets. And then other people. I mean, the examples are endless. It's ridiculous because every single object that's not like an image or reflection. Again, reflection is not the right word because this is all reflection, but that thing you think of as like a reflected image, glass and mirrors, is diffuse reflection. So there are so many examples. Whereas the other one is called specular, or spectral, I guess, spectral. I always say it wrong. Spectral reflection, and that is like a mirror. And so that is an example there. Lake, glass, all these things that the light reflects off, and you can see a reflection of something. Again, they're all reflection, but you see the image of something in that thing, and that's an example of that. All right, the law of reflection. So if this is an angle of 55 degrees coming in, then this must be 55 degrees as well, right? That's the law of reflection. It's the same. It happens the same. So the angle of reflection is 55 degrees, and the angle from the incident ray to the reflected. So this total angle here would just be added together at 110 degrees there. It's both of them, 55 plus 55. And if the student looks at the reflection in the mirror, how does the image size orientation compare? This is just ideas of images. A lot more on this next unit when we start actually changing the size orientation of the image here. So in this particular case, they're both upright. So if you're straight up, it'll be straight up, same size, and I guess kind of flipped. But that's just based off how you look at it. So upright, same size, and it technically is what we call an imaginary image. It's not a real image. You can't really capture it on a piece of paper and project it. It's just imaginary. You see the image, but you can't actually do anything with it. The light's not really coming together. And then finally, distance from the mirror to the image in a flat mirror depends on what? Distance from the object to the mirror, wavelength, or distance of both the observer and the object. No, where you look at it does not change how far away it is. The image is only based off where the object is. I believe the size of the object is supposed to be on this page, but I don't see it on here. I don't know what that is. Anyway, that is questions 4, 5, or 5, 6, and 7, page 3.